Hello students, today we will be continuing with our topic number 7, that is elements of group 16, 17 and 18. In today's session, we will be studying about anomalous behavior. This concept already we have studied in your 11th standard in the chapter elements of group 1 and 2. Based on the previous knowledge, let us consider a simple problem. The problem says the first member of a group usually differs in the properties from the rest of the members of the group. Why? Understand the meaning of this problem. We know that all the elements belonging to a particular group have same outer electronic configuration. So they must be similar in their properties. But it is observed that the first member of the group, it shows some term properties different from the rest of the members of the group. In this problem, they are asking us what are the reasons behind this observation. It is observed that the first member of the groups 1, 2, that is S block element, 13 to 17, that is P block element, exhibit different properties from the rest of the members of the group. The reasons behind this is they have a very small atomic size as compared to the other elements of the group. They have large charge to radius ratio as compared to other elements of the group. And they are highly electronegative in comparison with the other elements of the group. These are not the only three reasons. Certain other factors are also operative. And these factors include the maximum covalency of the first member of the group is 4, whereas the other members of the group can expand their valence shell to accommodate more than 4 electrons. This point means that the maximum covalency of the first member of the group is 4, whereas the other members can show valency greater than 4. The second other factor includes first member have a greater ability to form p-pi multiple bonds as compared to the subsequent members of the same group. This reason means the first member have a tendency to form multiple bond. In the formation of multiple bond, only p orbitals will be involved in the pi bond formation. But this tendency of the remaining members of the group is found to be lesser. And as a result of these 5 reasons, the first member of a group usually differs in properties from the rest of the members of the group. Just now in this problem, we saw that the first member of a group differ in behavior, that is properties, from the remaining members of the group. And hence we say that the first member shows anomalous behavior. Anomalous means somewhat different behavior. Let us see the group 16. The first member is oxygen. So in group number 16, anomalous behavior is observed in case of oxygen. The reason behind this anomalous behavior is small atomic size, high electronegativity, and absence of d orbitals. Oxygen belongs to second period. So the outermost shell in oxygen is second. Second period has only s and p orbitals. There are no d orbitals in the second shell. Now, what properties of oxygen differ from other elements? These properties which differ, they are called as anomalous properties. So now let us see the anomalous properties. The first anomalous property is oxygen is diatomic. So its formula is O2. Whereas the other elements are polyatomic. For example, sulfur formula is S8. Oxygen is paramagnetic. The paramagnetic behavior of oxygen you have studied in the chapter chemical bonding of 11th standard in the concept of MOT. Oxygen is paramagnetic in group 16, but the other elements are diamagnetic. Means oxygen show magnetic properties, whereas other elements do not show. Oxygen show -2, -1, and +2 oxidation states. Oxidation states of oxygen you have studied in detail in 11th standard in the chapter redox reaction. But other elements of the group, they show -2, +2, +4, and +6 oxidation states. Hydride of oxygen, that is water, it is liquid at room temperature. But hydride of other element are gases at room temperature. For example, hydride of sulfur, H2S, it is a gas. Common covalency of oxygen is 2. Means oxygen can form maximum 2 covalent bonds. In rare cases, it is having a covalency of 4. But for other elements, the covalency is always greater than 4. That is, it exceeds 4. So these are the anomalous properties of oxygen. Now let us take a simple problem based on anomalous properties of oxygen. Oxygen forms only OF2, while while sulfur forms SF6 with fluorine. Explain why. From the molecular formulae, it is very clear that one oxygen atom can form 2 bonds with only 2 fluorine. But one sulfur atom can form 6 bonds with 6 fluorine atoms. What is the reason behind this? Oxygen forms -2, -1, and +6 oxidation state. Other elements, they form -2, +2, +4, and +6 oxidation state. This is the anomalous property just now which we have seen. Oxygen cannot exhibit higher oxidation state like +4 and +6. Why? Due to absence of vacant d orbitals. Hence, fluorine can form only OF2, whereas sulfur can form SF6 with fluorine. See the second problem. Which of the following species possess hydrogen bonding? They have given hydrides of group 16, H2S, H2O, H2SE, and H2TE. We have studied that hydrogen bonding is present only in water molecule. Now, the third problem says that show hydrogen bonding in water molecule with the help of diagram. In water molecule, there are 2 OH bonds. Oxygen is more electronegative than hydrogen. So though basically the OH bond is a covalent bond, it gets some polarity. Oxygen is a negative pole with minus delta charge, and hydrogen is the positive pole with plus delta charge. So if I take 2 water molecules, the negative pole of one water molecule, that is oxygen, and positive pole of second water molecule, that is hydrogen, will get bonded by dipole-dipole interaction. This dipole-dipole interaction involves one of the pole as hydrogen, so that dipole-dipole interaction is called as hydrogen bonding. Normally, the bonds within the molecule are shown by normal dash, but bonds between the molecules are shown by dotted line. So hydrogen bonding in water molecule can be shown as follows. Now let us come to group number 17. The first element of group number 17 is fluorine. So it will show anomalous behavior. The reasons behind the anomalous behavior of fluorine are: number 1, small atomic size; number 2, high electronegativity; number 3, absence of d orbitals. These 3 reasons are similar to that of reasons for anomalous behavior of oxygen. But fluorine has one more reason which is not observed in case of oxygen. That is, to break the fluorine-fluorine bond, we require less amount of energy. Energy required to break a bond is called bond dissociation enthalpy. So in case of F2 molecule, FF bond dissociation enthalpy is low. Now let us see what are the anomalous properties of fluorine. Number 1, ionization enthalpy, electronegativity, and electropotential. These three values, if you compare it among fluorine and other elements, then these values are higher for fluorine and these values will be lower in case of other halogens. Ionic radii, covalent radii, melting point, boiling point, and electron gain enthalpy are quite lower. They are even lower than our expectation. If you see the reactions of fluorine, they are found to be exothermic in nature. Fluorine forms only one oxo acid, that is HOF, whereas other elements, they form a number of oxo acids. Now these oxo acids we will be studying in the latter part of the chapter. HF, that is hydride of fluorine, is liquid because it has a strong hydrogen bonding. Because of strong hydrogen bonding, its boiling point is found to be 293 Kelvin. But if you compare other hydrogen halides, then they are gases.